Hi, so I'm going to be doing my third genetics mini video on population genetics, and we're going to be using the character Trolls from the Trolls franchise as a image. So in a magical forest, there's a troll village with a population of 80 trolls. Out of these 80 trolls, 27 are pink, 37 are purple, and 18 are blue. The 10 color is an autosomal gene and is represented by these genotypes. So here we have the genotypes, the number of individuals, and the total number in the population represented in these pictures. We're going to come back to these pictures later. First, we're going to make sure that this population is Hardy-Weinberg equilibrium by doing a cast grid chart. So we already know our genotype and our observed numbers, so we can input those there. To find our expected, we need to calculate the frequency of the big B allele, which is going to be 0.56. This is also our p-value, as well as the little b allele, which is also our q value, which is 0.44. So then we can calculate our expected values by doing these equations. Once we get those expected values, we can put them in our chart and finish with our cast grid. So our degrees of freedom is going to be 1, which means our critical value is going to be 3.84. So 1.0394 is our calculated value and is less than 3.84. So our statistical conclusion is that we fail to reject that this population is Hardy-Weinberg equilibrium. We can also check this by inputting our values into these two Hardy-Weinberg equations and make sure they add up, and they do. So the natural predator of trolls are Bergens. Bergens think trolls taste delicious. Over time, the Bergens started believing that pink and blue trolls were tastier than purple trolls, so they ate less purple trolls than blue and pink. This selection changed the population of trolls over time. So how did it change? So we're going to fill out this chart. We already know the frequency before and the relative fitness by putting our p squared, 2pq, and q squared values, which is going to add up to b1. So to find the unadjusted survivors, we multiply our relative fitness by our frequency. We get these values with an average fitness of 1.1. So to find the frequency of the genotypes after selection, we divide the survivors by the average fitness and get these values, which turns out to equal 1 again. The allele frequencies after selection are calculated here, and those are 0.5985 and 0.4015. So this is going to be stabilizing selection. Over time, this would occur because the Bergens eat more pink and blue trolls since they're tastier, so it becomes more favorable to be a purple troll. This increases the fitness for purple trolls, causing heterozygotes to be favored in the population. However, there are still blue and pink trolls in the population. So here's a video to elaborate further. So you can see the Bergens going and eating the pink and blue trolls. So as our purple population increases, the pink and blue population is decreasing.